Hey, what's going on, folks? It's Mike here, and welcome back to the software design series. And this is the next part in which we're looking at the visitor design pattern and actually coding up the visitor design pattern. And then we're going to look at some of its trade-offs and benefits. So with that said, let's not have you wait any longer, and let's go ahead and dive in here, talking about the visitor pattern here. And we've already looked at the definition of it, but again, it's a behavioral design pattern. And a lot of behavioral design patterns, again, their goal is, as defined in the Gang of Four book, to focus on communication between objects, how they talk together. Visitors a little bit outside of that, and that it's focusing on, again, the structure, or rather modifying how the structure of the object is, such that we can add behaviors that, again, communicate something or are enforced by some sort of class hierarchy, as we'll see here. So again, the key advantage of the visitor, and we're going to see we pay a little price in complexity for this advantage of extensibility. So it's sort of a ideal pattern as defined here for building a public API that you can just plug into or, again, extend your system. Now, you'll see visitor used in lots of different domains. Again, we're going to continue on with our gaming example, but it could be used in things even like compilers and so on. So it's quite a flexible pattern. So anyways, with that said, let's go ahead and resume our project with this scary guy here, or friendly. Again, depends on which team you're on, I suppose. Anyways, so again, last time, if you watch the previous video, make sure you watch the previous parts so you can see how we've built this up and how we think about programming here with the visitor design pattern. Again, we have it's a very object-oriented solution, right? We have our behaviors and any data. In this case, we don't really have any data, but we could add some member fields here, all put together in some hierarchy here, okay? So what we're going to want to do here is look at this visitor design pattern. So here's the classic sort of UML, the Unified Modeling Language diagram of the visitor pattern here. Now, when I first looked at this was a little bit hard for me to understand sometimes looking at these. So I want to build this up a little bit slower here. And just see what we have here. So I'll move out of the way. This is what we had previously, right? We had this monster structure here, which served as our interface or our base class, and then two classes, an orc and a goblin, which inherited from monster. So what we're going to do here, and again, our goal is that we can move our behaviors, things like sing, outside of the orc and the goblin class, okay? And ultimately make it a little bit easier to extend the functionality of each of these monsters here. So what I basically want to do here is create another base class. And this is going to be called the Monster Visitor base class. And again, the purpose of this class is going to be to tell us what types of objects in this hierarchy. So again, we can see, if you look in the bottom corner here, orcs and goblins are things that we can basically visit. So I can visit the orc class here, or I can visit the goblin class here and add some sort of behavior to them, okay? So observe that these are, a way to implement this is with a purely virtual function. So again, this itself is an interface, the monster visitors. And that's sort of an interesting idea because this is an interface, monster visitor, if I forward us one more slide, we're going to have our behaviors as base classes for the monster visitor here. So if I want to draw the monster or have the monster fight or sing or whatever, that's where my behaviors are going to be. Okay, so again, I have a sort of separate hierarchy here on the left side, and then my separate hierarchy on the right side. So at this point, nothing's changed, right? I can go ahead and show you from our previous example, right? Looking at this code, nothing's changed with the right side of our hierarchy. It's the same. I've got a base class here and two subtypes or two derived classes here of monster. But if I go back to our slideshow here, again, now I've got this other hierarchy on the other side here, okay? Now the difference here, and I know it's a little bit small text, let's actually just make that a little bit bigger for you, just so you can see on the slide for a moment here. The monster visitor class says that I can visit these types on the left side. Now, this is why in the previous video I said it's kind of nice if you know you have exactly goblins, orcs, 2 or 3 or however many types you have, because then it becomes really easy to write this function. Not a big deal to extend it overall, but again, you have this here. Okay, so let's undo that change here and proceed forward. Now here's the next step here. Now, how do I get these two to communicate? Meaning, how do I get these behaviors, drawing and fighting, into the monster class here? Well, my monster base class now is going to have one single accept function here, okay, for the behaviors that I want to accept. And this is a kind of subtle idea here, but I want to emphasize this is really important, or really powerful, and a powerful use case of the visitor pattern is, well, I've got this hierarchy here called monster visitor. I could also have another hierarchy here called knight visitor or hero visitor, and maybe the monsters could also accept those types of behaviors, right? Or maybe just the goblins, but not the orcs. Okay, on this side could have the accept, lower in their hierarchy. So there's different ways that you can sort of compose this into a very powerful pattern here. But the idea is we're basically just taking in using a function call or a specific member function call that's taking in the visitor class that will define the actual behavior that happens. Okay, so that is the idea here. And we're enforcing what types of behaviors by using object-oriented programming in this particular instance. Now, stay tuned, stay subscribed, etc. for the next video, in which I'll show you how to get around that if you don't want to use an object-oriented style. Okay, and that was the point of the first video in this series for watching that. So anyways, we've got this accept here, and this now, again, I'll move out of the way just so you can see that change here. We've got accept, and then instead of having, again, specific behaviors like singing for each of the monsters, they can have accept and just accept the monster visitor so that they can be drawn and fight, right? They both have these capabilities now. Okay, so that is the idea. And, sometimes it's a little bit weird. Here's the code. I'm going to actually write it so it's a little bit bigger for you. But you can kind of read this as I accept some functionality from the monster visitor hierarchy, right? That's the accept here. And then the monsters, again, are the ones visiting these base classes to grab the functionality. Okay, so that is the idea with this terminology here. You'll have accept and visit most commonly labeled here. Okay. And then we can do things like write free functions or, well, here's the actual draw monster visitor here, which visits orcs and goblins. Again, I'm going to write this so that it's a little bit bigger for you, but this is just cleaning up the UML diagram, which I found hard to understand, and this a little bit cleaner. So anyways, that's where that fits, right? Here's the fight monster, and you'd have your draw monster, etc. Okay. Now, we tend to like this pattern because, again, what this means here is, one, it follows this nice other principle, right? In the previous video, we talked about don't repeat yourself, right? Where I was repeating code in goblins and orcs and so on for various behaviors. It follows this sort of open close principle, meaning that this class here, our monster, it's open for extensibility, but sort of closed for modification, right? So it's easy for me to add more behaviors, but I don't have to modify these actual classes, right? Maybe these were written 20 years ago and we're afraid to change them, but we do want to add some other, feature or behavior or something that makes sense. I don't know. I mean, that's the basic idea. Visitor pattern is great for extensibility. So again, this sort of, the algorithm or our behaviors, again, are on the left side of this hierarchy. So again, hopefully that's clear. I'll move out of the way just so you can see the picture again fully here. Okay. Now note that, again, as I mentioned, it's probably weird if I'm adding lots of different things like goblins and orcs and dragons and trolls, and whatever, centaurs and just other different creatures and eagles or whatever, which actually, I guess, good guys in Lord of the Rings. But the point is, this pattern tends to work better if you have a more concrete system, but that's not exclusive. That's just a general recommendation you'll hear from the community. The nice thing about this object-oriented solution is it sort of enforces that you have to implement, if you add another type here, like a troll, then I need a visit troll on this side and to handle each of those cases, which is fine. It's sort of organized as well. All right, so I'm going to actually write this code here. Let's go ahead and take a look here. And we'll start by modifying the previous example that we have here. So again, I've got this monster base class here. This is the same from our previous video, but just a quick recap. Orc inherits or derives from monster. Goblin derives from here as well. And we're going to want to get rid of basically our behaviors here. Okay, we don't need them for singing here. So let's start by getting rid of that. And then I'll just recompile this example here. And let's move these behaviors again out of our base class. And now we just have these objects constructed. So first and foremost, the first thing that I'm going to need to do here is let's go ahead and write our visitor class here. So again, I'm just going to use a plain struct. I'm going to call this the monster visitor. And let's go ahead and I'm going to go ahead and what should I do here? Let's create the monster visitor. Again, the destructor should probably be virtual here. I'll just use the default that it's generated for us. And then I want to write my object types that I can visit. So this means, again, I'm going to be able to visit orcs. And I don't need them. You could make them const. It's sort of up to you how you want to handle this. But this is going to be a orc. And maybe I don't want to modify it. Maybe I do. Again, you can sort of decide here. And then for the goblin as well. Now, because I'm using these types here in the same file, I am going to forward declare them. Orcs and goblins. Okay, just so that we compile at this point. Okay, so now that we have this much here, okay, this is just our visitor base class, okay, which tells us which type of objects, orcs, goblins, that we can extend, okay, which means i.e. visit, right? That's the idea here. We're able to visit them and extend them. I mean, this is similar. You might ask yourself this question: why can't I just write a free function like this called visit and take in orcs and so on? The answer is you can, and that would be fine. One advantage you get here with the object-oriented stuff by making these sort of interfaces is it forces you to implement some of the functionality so you don't miss something. So that could be an important reason. The other, again, is if you are building a application programming interface that you want to be extensible, it's probably easier to come up with some sort of interface like this versus just letting a user arbitrarily write free functions. So again, some things to think about, but that's the purpose here. Okay, so now that we have our monster visitor, both for our orcs and our goblins, now I need to accept that monster visitor. Okay, and again, this is just the base type here. Again, I could probably improve this code a little bit by putting I in front of everything, but just so it matches the slide, I will go ahead and just keep it as is. But let's see, let's have our virtual void accept, or actually this could just be a concrete function. Let's just make it void accept. And what am I accepting? Well, a monster visitor. And again, you can think about if it needs to be const and these types of things here. And then I always like to put override here when I am overriding some behavior. In fact, I'll show you where this is going to mess up in a second. Let me actually just compile it now. You know, this is going to cause a bunch of problems because we haven't written accept in our base class here, right? Which is something that I want as a, again, virtual void function, accept const monster visitor. And I could go with the, visitor or whatever, equals 0. Okay, let's go ahead with that. And then we need to do the same for our goblin. It needs to be able to accept a visitor. Here. And then let's see here. We are getting rid of some more errors, but we're not quite done because we need to actually implement some sort of visitor here. And then we can actually implement these visit functions here. So it's still complaining about visiting here. Okay, so let's go ahead and write our first visitor here. Again, let's kind of move some of these. We don't care about the errors quite yet here. And I'll go ahead and just create one here for now. Let's go ahead and create a struct here. Let's do something like, we did like the draw monster visitor here. And that's going to inherit from, well, monster visitor. Because again, we want this second hierarchy here, right? So we've got our monster visitor. Let me go ahead and just show you in the diagram here, right? We want this side of the hierarchy here, right? These are the behaviors that I'm adding, right? The ability to draw a monster here. So it's going to inherit from monster visitor. And okay, if I want to draw a monster, well, what do I need to implement? Well, I need to be able to visit orcs and goblins, right? So I need to override both of these functions here. Now, this is where the visitor pattern's sort of interesting, and we might sort of argue, you know, it's a little bit, you know, quite a bit of work here. Because I have to do this for each of the types here, right? I need to override for orcs, and I need to also override for goblins here, okay? Why do I need to do that? Well, let's look at our monster visitor, right? Here's all the types that I need to do that for. Okay, so I'm defining that here for my monster visitor base class. So this is good, again, in the sense that I don't forget to support something in this hierarchy. It's bad in the sense that I am maybe writing a lot of code. It's good in the sense that I think I'm grouping all the code for how orcs and goblins and just anything to deal with drawing of these different types is sort of in one place. I actually really like that. You know, in this structure or this particular example. Now, I know I could split these up into different files or whatever and move this wherever I want, basically, but I sort of like that. And it's also potentially an interesting pro or con depending on what I'm putting in the visitor here. Now, drawing is probably something I want to handle somewhere else, right? A goblin or an orc probably has a member function for a mesh, and then the visit or draw code, maybe that is part of the base class, right? It just takes in triangles and a texture to draw. But anyways, this is just an example here. So let's go ahead and try to compile this here. Let's see what I'm missing here. Otherwise, getting a few different errors here. Let me go ahead and scroll up before I implement these here. Let's see, we've got our monster. We've got, oops, maybe just what looks like a type error here. Let's go ahead and add our orcs here. And our goblins, something like that here. Okay, so that should do the trick here. Okay, so I'll make this small for just a moment here, just so you can see, again, the structure here. Again, we've got our visitor hierarchy here. Now, if it's helpful, let's actually, we can group these together just so the hierarchies are sort of around each other. Let's do that. That's just a little bit more logical. So we've got our monster visitor, the new behaviors for our monsters, and then we've got our monster hierarchy here, which can accept the different behaviors here. Okay, so how do we actually do something here? Well, let's kind of print some stuff out here just so we can kind of see here. So when we're drawing orc from monster visitor, so just to give us some messages here. And let's do the same thing for our goblin. Drawing goblin. And, well, if we want to do anything specific here, as far as drawing our monster, right, we're able to, and again, this was one of the reasons why I use a struct, unless I had a reason to hide information. I basically have access to the public API of orc and goblin, okay? So anything that I do need to expose, I could write a getter or setter function. That could be okay. Again, you have to think about it for your use case. So that is potentially a drawback of the visitor pattern, that you're basically relying on the public API to do stuff. But again, if you're writing a plugin system, right, so your gameplay designers or whatever, or you as a gameplay programmer can basically control how the monsters are drawn, right? You probably should, in a plugin interface, be using the public API anyway. So that, again, could be a pro or a con, but just some things to think about. Now for the accept, if we actually pass in a monster visitor here, let's just actually write out, I'll just write orc accept, just so we know which one's being called here. And let's go ahead and do goblin accept. And then how to actually do the work here. And this is going to be the line that you effectively copy and paste over and over and over. You do visitor dot visit, and then, well, what's the object that you're visiting? Well, it's this object. Okay. this particular goblin. And again, you can see I'm just going to effectively copy and paste the same thing for the orc here. Okay, so let's go ahead and compile that. Compiles and runs. And now let's actually do something with this here. Okay, so let's create a orc here and give it the ability to fight. And then we'll maybe do this for a collection of them. Okay, so I'm just going to create a new monster, my monster. And this I can make a little bit bigger just so you can see how it works here. My monster equals new monster. Again, use some of the things like, you know, you can make this a unique pointer or whatever. That's probably a good idea here. And let's see, I want the, let's see, we implemented the ability to draw. Okay, so we'll just do the drawing here. So I've got a draw monster visitor here. So let's just go ahead and lay that draw monster visitor, DMV. Okay, fair enough. And then my monster, what I'm going to do here, it's a pointer here, is accept this ability to draw. Okay, let's go ahead and run this code, see what happens. Oops, looks like I made an error here. I can't instantiate this abstract class here. We said it was going to be an orc, so there we go. Let's go ahead and do that. And now I have created my orc. I am accepting the behavior here when I call this and drawing from the monster visitor here. Okay, so hopefully that makes sense. I've effectively just added or created this behavior here and added it to my object and executed it by accepting, because that's the only thing our monsters can do, right? They can only, whether it's the goblin or in this case I chose the orc here, it can just accept different behaviors from this particular hierarchy here, the monster visitor hierarchy, right? For drawing, and it's got a particular way for drawing here, okay? Now, of course, you can extend this. This is where you could use some, you know, void draw all monsters, and then let's take in your vector of monsters, and then again, this could be like by const here, the monsters, and let's go ahead and say for, we'll do a range-based for loop here, and maybe we don't want to modify any of the monsters here. Oops, let's go ahead and call this monsters. Let's make it a little bit longer here. Monsters. Then I'll actually do M. Let's see, because this is a bunch of monster pointers. And except I could just create a, you know, empty object here. Draw monster visitor here. Okay, which is the one that we implemented here. So let's actually try that out here. So after creating our goblin and our orc, we'll call draw all monsters. Let's pass in our monsters, and they're going to use this default draw monster visitor here. Okay, and let's give ourselves a little bit of space here between our experiments. Go ahead and run this. Okay, so we've created our orc, we've created our goblin. For each of these accept functions, we're accepting for the orc, drawing the orc, we're accepting for the goblin, which is the second thing in our vector that we're passing into this draw all monsters function. And then we do the goblin accept and then draw with the goblin routine here. Okay, so this is an easy way to, again, now write a, you know, function that accepts all the behaviors here. And we could make this an even more flexible function, right? It could take in the monsters collection and a behavior after, sort of as a strategy. So you can combine this visitor pattern with strategy and other sorts of patterns here. Okay, so let's get a overview of the full code just so you can, you know, see it all in one. The important thing was first forwarding these structs, and then our monster visitor class, which tells us which types of objects we can visit, things like orcs and goblins, right? All the things in our monster hierarchy effectively is what we want to support here. Then we've got our monster draw monster visitor behavior. This is effectively the same as adding these this ability to draw, or, you know, whatever, as member functions individually to our monsters. They come through the monster visitor class. And then we change our base class monster here to accept the monster visitor, and we could accept other types of visitors too. That would be fine, right? Maybe we've got a artificial intelligence visitor, maybe we've got a physics visitor, and, you know, different subsystems basically that can affect how monsters work in this game, for instance. Or, you know, there's different ways you could break this up, but that's the idea. Then we've got, again, our orc here and our, which implements monster, and then it accepts, again, the monster visitor, because that's part of our interface now to accept that. Okay. Now, again, you could have explicit or different, right? If orcs were fundamentally different than goblins, but still needed to be part of this hierarchy, they could have their own accept orc visitor, you know, behaviors or something. Again, just kind of depends on what you want to do here. Okay. And then here was actually using it. Here's like the simplest example of just creating a monster, and then you're adding dynamically, in effect, you know, the different behaviors here by creating a behavior and then executing the behavior here, right? Rather than just calling the member function directly. So that leads us to kind of getting to a wrap up here, right? We've looked at the code here. And again, you know, here's a summary of the main ideas. I'll move out of the way so you can see this. In my slide example, I also added, you know, fight monster visitor. That's a good exercise for you if you want to go ahead and add just to see how this works here. And then you can have a, you know, monster fight function or whatever. And here's how you do the fight monster. But, you know, to summarize this pattern, it's really interesting, and it's worth you thinking about some of the pros and the cons. I mean, immediately you've already watched a 26+ minute video plus the other parts to understand this. So, you know, think about what some of the pros, cons are of this. All right. And if you thought about that for a moment and paused it, I'll go ahead and move us forward here. So some pros, you know, we've got the open close principle. This is a very nice pattern, in my opinion, if you want to extend behaviors. Okay, it's a pattern that you can use. It's kind of nice that you're hiding the details behind the scene and only using the public interface. That's probably the right way, right? If you've got a good public interface, that's sort of the point here, that's what you're exposing to do various behaviors. You know, the neutral part is we might still be repeating some code actually here, but at least it's sort of in the same struct or class or area. So I'm not totally against that. And I sort of like having the pure virtual functions that ensure like everything gets implemented so I don't forget, right? Even if that behavior might happen to be empty for that object, or you want to throw an assert in there to ensure, you know, that goblins can't or orcs can't jump or do some like weird behavior while they're fighting. That might be okay during development time. So again, I'm kind of neutral about that. Now the cons here, and my list is actually bigger, so that means it's kind of specific when you want to use the visitor pattern, right? Plug in functionality using a public API. You know, potentially it's harder to introduce new types. I'd say that's not possible. That's maybe more, you know, it's not impossible. It's probably more of a neutral thing. Again, you are restricted to the public interface. You know, maybe there are instances where you don't want to expose certain things and it encourages you. Why I've listed this as a con is it might encourage you to make more things public than you want in your interface as so consider that maybe neutral as well. There is this other sort of con here which makes it kind of interesting, and maybe this is why I don't know if it was actually used in this game here, is you do have lots of polymorphism. This is actually something known as double dispatch, right? This idea, if I go here, right, here's one level of sort of indirection here, right? I'm creating some type of monster. Okay, it's an orc. So always, you know, chase the right pointer and do the orc version of accept. But then I'm also chasing this here, draw monster visitor, which is in its own sort of hierarchy here. Okay. So there's sort of a double dispatch here, which could hurt performance, you know, quite a bit here. You know, in a game, usually you're using some kind of entity component system and just trying to avoid as much of these sort of hops as possible. Now, that's not to say, it just kind of depends on what type of program you're making and where you have budget. And by budget, I mean time or milliseconds in a gaming example to spend on behaviors. Maybe this is a great way to create really innovative gameplay. Maybe you don't have, you know, really intense graphics or something, so this works perfectly. Or maybe you're just doing a lot of setup stuff at compile time to do something interesting, so it doesn't really matter. So you do have to think about that. We are allocating lots of things on heap. There's indirection here. So a few things to think about. There's also the sort of natural complexity that comes with this pattern, right? We did have to actually, if we go back to the code, and this is where we'll wrap up, we did have to think about this. If somebody is new on your team and doesn't know the visitor pattern, or things aren't clearly labeled, right? You should probably label something with visitor on it. Then it's not necessarily obvious that you're using this to extend behaviors. But, you can also argue, on the other hand, that it really cleans up your code here. When you have this is all my classes for a goblin, right? And then I can add that attribute struct that we talked about in the previous video, and this becomes pretty clean to create new objects and then implement their behaviors all in, specific structs here. I think it's not necessarily a bad thing, right? Again, we're separating things out here. So anyways, folks, that's where I'm going to wrap it up here. Again, just kind of scrolling through the code. I hope you enjoyed this lesson here. We are going to look at a bonus part 4 here, just to show another version of the visitor that takes advantage of some different programming paradigms. Again, so sort of circling back to the first part of this series in the first video. So anyways, folks, if you're enjoying this, feel free to check out my website at courses.mshot.io for other C++ lessons, and there's full courses available as well. Thanks as always for your time and attention. I hope you've enjoyed this sort of in-depth look at visitor pattern. That's a good one for you to try to code up yourself. And if you understand this pattern, you can understand any of the Gang of 4 patterns, because I think this is one of the more complex ones. Anyways, folks, with that said, thanks for your time and attention. I'll look forward to seeing you in the next video.